Happy Friday! The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All righty, so today we're going to go on and look at the second part of section 10.2. But before we do that, I've got a couple of questions that came in. So I want to look at those first of all. So this is from section 10.2, part 1, which was introducing the quadratic formula. So this first problem, this is number 18 from that section. It says, use the quadratic formula to solve the equation. Enter your answers as a comma-separated list. And the equation is the following. It says 60b squared plus 60b minus 20 equals 0. This equation is already in standard form. That is, terms are in descending powers of the variable b. We could take out a common factor of 20. So we can divide each term by 20 to reduce this thing down to smaller numbers. Doing that, we get 3b squared plus 3b minus 1 equals 0. So now we have a equals 3, b equals 3, and c equals -1. Now, be careful. This b and this b are not the same. The b that's in the equation is the variable in the equation. The b that's down below just stands for the coefficient of the linear or first degree term. So just careful with that. All right, now we're solving for b rather than x. Again, this is gonna be confusing because we've got b in both places. So b equals -3 plus or minus the square root of 3 squared minus 4 times 3 times -1 all over 2 times 3. Okay, any questions on that? All right, so simplifying further, we get b equals -3 plus or minus the square root of 3 squared, which is 9, minus 4 times 3 is minus 12 times -1 would be plus 12 all over 6. Okay. So now we've got b equals -3 plus or minus the square root of 21 all over 6. Okay. And we could split that up and get -3/6 plus or minus the square root of 21 over 6, which would give us -1/2 plus or minus the square root of 21 over 6. Okay. You also should be able to just leave the two answers like this, except that you'd need to write them separately. So you'd say -3 plus the square root of 21 over 6, comma, -3 minus the square root of 21 over 6. Okay. Again, I'd ask you to separate the two solutions with a comma. All right, let's take a look at number 19 in that same section. Here we have an equation with decimals, 6x squared plus 0.7x equals 0.06. So if we want to make life easier, we'll get rid of the decimals first. The term on the right, the constant, we need to move the decimal point 2 places, so we'll move everybody 2 places. We'll multiply everybody by 100. On the left side, we get 600x squared plus 70x equals 6. I'm going to subtract 6 from both sides of the equation. 600x squared plus 70x minus 6 equals 0. let's see here, 2 places. It's a small thing, but all the coefficients are even. So we could come in and divide everybody by 2 just to make things a little bit smaller. We get 300x plus 35x, 300x squared, excuse me, plus 35x minus 3 equals 0. Okay, so we've gotten rid of the decimals. We've reduced things down. Let me double check here to make sure I've done everything correctly so far. Got the problem copied correctly, multiplying by 100, 2 places, 2 places. Okay, move that over, divide by 2. Looks good. Okay, so now A is 300, B is 35, and C is -3. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So X equals -35 plus or minus the square root of, let's see, 35 squared. 35 squared is 1225. Okay. Minus 4 times 300 times -3 is going to be positive. So we're going to have what? 4 times 300 times 3 is going to be a positive 3600. And that's all over 600. So then X equals -35 plus or minus the square root of, let's see, 3600 plus 1225 is 4825, and that's all over 600. Okay, so now we've got this awful thing going on there with this 4825. First thing I'm going to do is see if that's a perfect square. So I'm going to take the square root of 4825. It doesn't come out nicely, doggone it all. Oh well. So now we're going to have to simplify that down. What I'm going to do is I'm going to take this and take it to the next page so that I've got more room to work. So X equals -35 plus or minus the square root of 4825 all over 600. Okay. 4825. Well, I can see that 25 goes into it. Let's see how many times 25 goes in. So if I take 4825 divided by 25, I get 193. Okay, 193. I don't think there's any perfect squares in that. So this is going to equal that, is going to equal that. Okay, so then I've got X equals -35 plus or minus 5 square roots of 193, all over 600. Well, now I'm going to split this up into -35 over 600, and then plus or minus 5 square roots of 193 over 600. I can take -35 over 600 and take out a 5 and get -7 over 120. Okay. Plus or minus, I can take 5 over 600 and reduce it down to 1 over 120. I don't really need that 1 there, it's implied. So my answers are X equals -7 over 120 plus the square root of 193 over 120, comma, -7 over 120 minus the square root of 193 over 120. Okay. Or I could also have X equals -7 plus the square root of 193 all over 120, leaving it as a single fraction like that. So you could either have it split up, or in other words, split up here, or as a single fraction, either way. Okay, well, that takes care of those. So now we're going to go on and look at some application problems in the second part of section 10.2. And the first thing we're going to deal with is a right triangle. So let me draw a right triangle. Okay, it says the hypotenuse of a right triangle is 2.5 units long. The longer leg is 1.7 units longer than the shorter leg. Find the lengths of the legs of a triangle. All right, when we're dealing with a right triangle and we're dealing with the lengths of the sides, we're going to be using the Pythagorean theorem, which says a squared plus b squared equals c squared. Now, where do we get a, b, and c? Well, with a right triangle, the hypotenuse, the long side, is called c. The long side, or the hypotenuse, is always going to be across from the right angle. So this is going to be c, called the hypotenuse. The other two sides are called the legs of the triangle. One of them is A and the other is B. It doesn't matter which one we call A and which one we call B, as long as we're consistent throughout the problem. So the length of side A squared plus the length of side B squared equals the length of side C squared. There you have the Pythagorean theorem. Now, it says the hypotenuse of a right triangle is 2.5 units long. So 2.5. The longer leg, in this case, B is the longer leg, is 1.7 units longer than the shorter leg. So what if we call the shorter leg x? Then the longer leg would be x plus 1.7, because it said the longer leg is 1.7 units longer than the shorter leg. Okay, so A is x, B is x plus 1.7, and C is 2.5. Now, plugging those into the Pythagorean theorem, we get the following: x squared plus x plus 1.7 squared equals 2.5 squared, which gives us x squared plus x plus 1.7 times x plus 1.7 equals 2.5 times 2.5 is 6.25. Let me verify that. Yes, it is. So now, continuing, we get x squared plus x squared plus 1.7x plus 1.7x plus 1.7 squared, I think, is 289. Let's see here, 1.7 squared. Yep, 2.89, excuse me. Okay. Oops, I messed up there, didn't I? Hang on. The plus 2.89 is still on the left side, and then on the right side we have 6.25. Once again, proving I can't walk and chew gum at the same time. All right, so now combining like terms on the left side of the equation, we've got 2x squared plus 1.7x plus 1.7x would be 3.4x plus 2.89 equals 6.25. I'm going to subtract 6.25 from both sides of the equation. So I get 2x squared plus 3.4x. And then let's see here. 2.89 minus 6.25 is going to be minus 3.36 equals 0. All right, so I've got my second degree or quadratic equation in standard form, descending powers. I'm going to go ahead and get rid of the decimals. So to do that, I'm going to multiply both sides by 100 because I need to move it over 2 places because of the 3.36. So now I've got 200x squared plus 340x minus 336 equals 0. Okay, well, let's see. 200, 340, and 336, they're all even, so I could divide them all by 2. In fact, I think I could divide them all by 4. 4 goes into 200, 340, 330. Yeah, okay. So let's divide each term by 4. Now, 200 divided by 4, I'm going to get 50x squared plus, let's see, 340 divided by 4 is 85x minus 336 divided by 4 minus 84 equals 0. So that is what I'm going to take to the next page to solve. Okay. Let's see here. I've got 50x squared plus 85x minus 84 equals 0. Before I go on, I think I'm going to go back and just kind of double check everything here. X squared, x plus 1.7 squared, 2.89, 4. Okay, multiplied by 100. Everything's looking good so far, I think. We'll find out. So A is 50, B is 85, and C is negative 84. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative 85 plus or minus the square root of, let's see here, 85 times 85 is 7225. I need to tell you, if you haven't figured out already, these problems in this last part of this section, the numbers get really big. It's a good thing, you know, you can use a calculator. All right, then I've got minus 4 times, let's see, minus 4 times 50 would be minus 200 times negative 84, which is going to be positive. So 4 times 50 times 84 is 16,800 all over 2 times 50, which is 100. Okay. Continuing on, x equals negative 85 plus or minus the square root of, if we take 16,800 plus 7225, we get 24025 all over 100. Well, last time we had a huge number like this, I hoped it was a perfect square, and it wasn't. Let's see if 24025 is a perfect square. So I'm going to take the square root of 24025. It is. It comes out as 155. So sometimes things work out nicely. All right, now I've got x equals negative 85 plus 155 over 100. X equals negative 85 minus 155 over 100. So taking the top one, let's see here, negative 85 plus 155 is 70 over 100, or 7/10. I'm going to write that as 0.7. And why am I going to do that? Just because there were decimals in the original problem. I don't have to. I could leave it as 7/10, but I happen to know that the book went with decimals, but either one works. Okay, negative 85 minus 155 is negative 240 over 100. And that, see here, divided by 100 would be negative 2.4. So I've got 0.7 and negative 2.4. The problem is, if we go back to the original problem, x is a length or a distance. And we got a negative answer as one of our answers. A distance or length can't be negative. So even though this solution would work for the equation we created, it doesn't work for the actual problem. So this answer is not valid. This answer is valid. Okay, so if x is 0.7 and that's units, so that would be what, side A? So side A. Side B is x plus 1.7. So that would be 0.7 plus 1.7, which is 2.4 units. So side A is 0.7 units, side B is 2.4 units. Long problem, I know. So what did we have to do? We had to set up the triangle, use the use the Pythagorean theorem, FOIL things out, get it in standard form, get rid of the decimals, reduce it down, use the quadratic formula. All this, just one problem. I know, sometimes they get overwhelming. Okay. Next one, it says IMAX screens. The largest permanent movie screen is in the Panasonic IMAX Theater in Darling Harbour, Sydney, Australia. At least it was at the time of this book being printed. The rectangular screen has an area of 11,349 square feet. Okay, so now we're dealing with a rectangle rather than a triangle. And we know that the area is 11,349 square feet. Find the dimensions of the screen, so that would be the length and the width, if it is 20 feet longer than it is wide. So the width, we're going to call X, and the length, it says, is 20 feet longer, so it'd be X plus 20. Okay, now the formula for the area of a rectangle is area equals length times width. So that gives us the following equation. 11,349 equals X plus 20 times X. Okay, so then we get 11,349 equals equals X squared plus 20X. Now, I'm going to put everything on the right side so that my X squared, my leading term, has a positive coefficient. So I'm going to subtract 11,349 from both sides of the equation. 0 equals X squared plus 20X minus 11,349. Okay. I've got no decimals, no fractions, and I don't think I can reduce that down any. So going on from there, A is 1, B is 20, and C is negative 11,349. Okay, so X equals negative B plus or minus the square root of B squared minus 4A C all over 2A. X equals negative 20 plus or minus the square root of 20 times 20 is 400. Minus 4 times 1 is minus 4 times negative 11,349 is going to be positive. So let's see, we've got 4 times 1 times 11,349, and that is 45396 all over 2. So then X equals negative 20 plus or minus the square root of, let's see, 45,396 plus 400 is 45,796 all over 2. Well, let's see if 45,796 is a square. It is. The square root of it is 214. So we get that, okay? Which leads us to, let's see here, X equals negative 20 plus 214 over 2. Let's see what that would be. That would be what? Negative 20 plus, plus 214. So that's 194 divided by 2 is 97 feet. X equals negative 20 minus 214 over 2. That would be, let's see, negative 20 minus 214 is going to be negative 234 divided by 2 is going to be negative 117 feet. But again, you can't have a negative length, so this one isn't going to be valid. So this is going to be 97 feet. 97 plus 20 would be 117 feet. So the width is 97 feet. The length is 117 feet. Okay, let's see here. Let's take a look at this problem. It says picture framing. The matting around the picture has a uniform width. How wide is the matting if its area equals the area of the picture round to the nearest 100th of an inch? Okay, so we've got this picture. Let me make a drawing, attempt to make a drawing of the picture. Let's see here. Here. Oops, that didn't work. Let's try it again. There we go. All right, so inside we've got this picture. And like this. All right, and inside here we've got this picture of this sailboat and some trees, some clouds and some trees. And obviously I'm not an artist. And they tell us that this dimension from here to here is 4 inches. Okay, so the height of just the picture itself is 4 inches. And the length of the picture itself is 5 inches. Okay, so the inside picture is 4 times 5 inches, which would mean the total area of the inside picture would be 20 square inches. Now, let me go back. It says the matting around the picture has a uniform width. So this matting, this stuff here and here and here, that goes all the way around it, even though I didn't draw it perfectly, it's the same width all the way around. Okay, it's kind of like the frame. It says, how wide is the matting if its area is equal to the area of the picture, round to the nearest 100th of an inch? Okay, now we know that the area of the picture is 20 square inches. Okay, we know that the area of the matting is equal to the area of the picture. So I'm going to say area of picture plus area of mat equals what? 20 plus 20 square inches. So the total area equals 40 square inches. The picture plus the mat. Okay, so everything, total area 40 square inches. Any questions on that?
No, thank you.
Okay, now we have a little square here and a little square there and a little square there and a little square there. Since the mat is uniform all the way around, this distance would be x, as would that distance. This little piece there and this little piece there, that's x, that's x, that's x, that's x, that's x, that's x. And I'm just calling it x, you know, some variable. Okay, now if that's true, what would this total distance be all the way to the outer edges of the picture? Well, it would be x plus what, 5 inches? So it would be 2x plus 5. Are you okay with where I got that?
Yeah.
Okay, likewise, over here, this is going to be x plus 4 inches. So 2x plus 4. So the total area, 40, equals the length, 2x plus 5, times the width, 2x plus 4. Are you okay with where I got the equation?
Yes.
Right. 40 equals, I'm having a hard time drawing those equal signs today, equals 4x squared plus 8x plus 10x plus 20. 40 equals 4x squared plus 18x plus 20. Subtract 40 from both sides of the equation. 0 equals 4x squared plus 18x. 20 minus 40 would be minus 20. All of my coefficients are even, so I'm going to divide everybody by 2. 0 equals 2x squared plus 9x minus 10. Okay, so now I'm going to take that second degree or quadratic equation, go to the next page. 0 equals 2x squared plus 9x minus 10, and plug that into the quadratic formula and solve for x. A is 2, B is 9, and C is negative 10. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A, which is negative 9 plus or minus the square root of 81. Minus 4 times 2 is minus 8 times negative 10 would be what? Plus 80 all over 4. X equals negative 9 plus or minus the square root of 161 all over 4. Now, I want to go back and look at the directions again. The last thing it said was round to the nearest hundredth of an inch. That's a clue that unlike those last problems where the square root came out nicely, this one is not going to come out nicely. We're going to have to round it, okay? So let's go to both solutions and see what we get. So negative 9, so I'm going to go, let's see here. Okay, parentheses, negative 9 plus the square root of 161, close up the square root, close up the whole thing, divided by 4, and I get 0.922144, etc. Got too many 2's there. Anyway, rounding to the nearest hundredth, this would round down, so it's going to be 0.92. Okay. Second one, parentheses, negative 9 minus the square root of 161. Close it up, close the whole thing up, divided by 4. And we get negative 5. Well, it doesn't really matter because we're dealing with a distance, right? So the negative isn't going to work. So x is 0.92, and that was inches. Okay, the area was square inches, so x is 0.92 inches, and that is, so that mat that goes around it is a little bit less than an inch across. Okay, let's see, how are we doing for time? Okay. This one is kind of tricky in terms of setting it up. It says Central Park is one of New York's best known landmarks. Rectangular in shape, its length is 5 times its width. Okay, so we've got this rectangular park. We'll call this the length and this the width. It says its length is 5 times the width. So if we call the width x, the length would be 5x. Okay so far?
Yeah.
When measured in miles, its perimeter, so the perimeter would be the distance all the way around it, exceeds its area by 4.75. Okay. So here's what I want to do. The area would be what? 5 times x, or the area would be 5x squared. So the area of the park is 5x squared. Length times width. The perimeter would be 2 times the length plus 2 times the width. So that would be 2 times 5x plus 2 times x, which is 10x plus 2x. So the perimeter is 12x. Okay. Now it said rectangular in shape, its length is 5 times its width. When measured in miles, its perimeter numerically exceeds its area by 4.75. Now, what do they mean by numerically? Okay, they're not the same units because the area is going to be square units and the perimeter is just going to be units. So they're saying just looking at the numbers, okay? So the number of the area compared to the number of the perimeter, okay? It says measured in miles, the perimeter numerically exceeds the area. So the perimeter is greater than the area, right? It exceeds it. How much does it exceed it by? 4.75. So if we want them to be equal, we've got to add 4.75 to the area. Okay. How are you doing?
So it's saying that for them to be equal, we need to add 4.75 to 5x squared.
Yeah, because it's saying the perimeter is 4.75 greater than the area. So if the perimeter is greater than the area, you'd have to add 4.75 to the area to make them equal.
Okay, that makes sense.
All right. So now we're going to subtract 12x from both sides, and we're going to get 0 equals 5x squared minus 12x plus 4.75. I'm going to take that and write it on the next page. 0 equals 5x squared minus 12x plus 4.75. So again, I subtracted 12x from both sides. Got that. I'm going to multiply both sides by 100 to clear the decimals. So I get 0 equals 500x squared minus 1200x plus 475. I could take a 25 out of all of those. So I'm going to divide by 25, divide by 25, divide by 25, divide by 25. And I get 0 equals, let's see, what's 500 divided by 25? 500 divided by 25 is 20x squared minus 1200 divided by 25 minus 48x plus 475 divided by 25, 19. Okay. Okay. So A is 20, B is negative 48, and C is 19. X equals negative B plus or minus the square root of B squared. Notice the negative is inside the parentheses. The whole thing is B. So when I square that, it's going to be positive minus 4AC all over 2A. X equals negative times negative is positive 48 plus or minus the square root of, let's see, negative 48 times negative 48 is going to be 2304 minus, let's see, 4 times 20 times 19 is minus 1520 all over 2 times 20 or 40. X equals 48 plus or minus the square root of, let's see, 2304 minus 1520 is 784 all over 40. Now, let's see here. Where did I go with this? Somehow I got the page turned. Let's see. It doesn't say anything about rounding. Okay, so hopefully it's going to come out nicely. Let's see, what's the square root of 784? Ah, it's 28. That's why it didn't say anything about rounding. Okay, so the square root of 784 is 28. So x equals 48 plus 28 over 40, or 48 minus 28 over 40. Let's see here. 48 plus 28 over 40. 48 plus 28 is 76. Divided by 40 would be 1.9. And then 48 minus 28, which is 20 over 40, equals 0.5. Okay. Now, okay, we've got two possible answers. Let me read the entire set of directions again, because there's a statement at the very end that I didn't read yet that's going to make a difference. It says, Central Park is one of New York's best known landmarks. Rectangular in shape, its length is 5 times its width. When measured in miles, its perimeter numerically exceeds its area by 4.75. Find the dimensions of Central Park if we know that its width is less than a mile. Okay, x is its width. So in this case, this answer, even though it's positive, isn't correct because we're told that the width is less than a mile, and these units are miles. Okay, so it's got to be 0.5. And this would be what? 2.5. So the dimensions would be what? 2.5 miles by 0.5 miles. All righty. So there you have it. So it's probably going to be calculator time because of these huge numbers that you're going to be dealing with, but it'll be practicing using the quadratic formula. Don't forget the area of a rectangle, length times width, the perimeter of a rectangle. The perimeter equals 2 times the length plus 2 times the width. And then, of course, the Pythagorean Theorem. A squared plus B squared equals C squared, where C is always the longest side or the hypotenuse. All righty. Have a good weekend. And I'll be back at, let's see here, 1:15 today with an office hour if you have any questions.